What's up, everyone? Do you know you could now resize the CPU and memory in Kubernetes pods without restarting your pod? No more pod terminations, no more downtime, just pure live scaling. Let's dive into Kubernetes in-place pod resizing. So what's the challenge? Let's go back in history. Previously, changing a pod's resource such as CPU or memory meant recreating the pod. That often caused downtime, connection drops, or service disruption. For organizations running critical workloads, this has really become a huge pain. But from Kubernetes version 1.33, Kubernetes now allows us to resize resource limits of a container inside a running pod despite being in running state. This is a breakthrough for many production grade systems. I am sure many organizations building on Kubernetes will be quite excited about this new feature. So, what is in-place pod resize? It is a Kubernetes feature that lets you increase the CPU and memory of containers running in a pod. You can request a resize by updating the desired resource request or limits in the pod specification. This is typically done using kubectl patch, kubectl apply, or kubectl edit by targeting the pod's resize sub-resource. There are two resize container policies. The first one being restart policy, not required. This policy applies the resource change to the running container without restarting it. The second one is restart policy, restart container. This will restart the container to apply the new resource values. So container resize policies typically help you to control whether a container should be restarted when resizing by setting a restart policy in the container specification. So in terms of use cases, this is perfect for apps with variable workloads, or scenarios where you want to apply real-time tuning, or you want to carry out auto-scaling scenarios where downtime isn't acceptable. Such use cases are payment processors, streaming services, or software as a service platforms. Now, let me show you how this new feature works. To begin this demo, I would like to show you what my pod looks like. This pod is called CPU monitor. It runs an Nginx image. So within this container argument, I'm just running some bash script to get the CPU parameters in real time. But I want us to pay attention to the resize policy, which I talked about earlier on. So you can see that I have resource name CPU and the restart policy is not required, meaning that when I change this value, the container will not be restarted. For resource name memory, I want a restart to happen. And this is because for many applications, changing memory dynamically pose a different kind of challenge. So it's common to use a restart policy that restarts container for this particular feature. Then if you go back to the resource, I have a 200 millicores CPU, and this is what we are going to change. We're going to change this to 300 and check whether the pod will get restarted or not. So first of all, let's create the pod. So I'm going to go ahead to create the pod now. The pod has been created. So the next thing we need to do is to keep on watching the pod. The pod is in running states. I can also try to get logs from the pod. So while the pod is installing some of the packages needed, you can see the CPU limit value is 200 millicores. That is being tracked constantly. So let's try to patch this pod by setting the value to 300 millicores. So I'm going to basically run patch command with sub-resource resize. So you notice the pod is still in running state and there's no restart. If you go back to the logs, you can see that the new CPU limit is now 300 millicores. So this is how simple it is for you to do an in-place resize, be it CPU or memory. If you've enjoyed this video, please subscribe to the YouTube channel so you can get more videos like this. Thank you.